Good afternoon, students. So let's start the class. I think all of you have joined. So we will start the connection of your laboratory of your CT and PT, the different types of components of current transformer and potential transformer. So both types of transformer, that is CT and PT, are a type of a instrument transformer. So both are related with your instrument transformer. So those instrument transformer, when you bifurcate those transformer, you will get named as your current transformer and current transformer and voltage transformer, CT and PT, or you can say current transformer or potential transformer. Normally, current transformer measures the your current of the high voltage side, and PT, that is potential transformer, measures the potential or voltage of the high voltage side. So what is normally first the word you have heard about instrument transformer. Now, what is instrument transformer? As in the normal transformer, you already have studied your normal transformer. What is normal transformer? What is two-winding transformer? Then power transformer, distribution transformer. Those are the topic that you have already studied in your electrical machines part. But in this laboratory workshop, we were going to study about the different components of the instrument transformer. That is your CT and PT. So let us first demonstrate. Let us know about first the what is an instrument transformer. Before the instrument transformer, now normally the transformer principle works on the principle of electromagnetic induction. That must be applied in all type of transformer. Here also in instrument transformer, that principle concept is applied in instrument transformer. So normally as we know, normally the power system mainly utilize this type of transformer, because the power system is mainly AC system, in which transformer is mainly used to regulate the voltage and current across the transmission line, whether we want a high voltage side or low voltage side. Low voltage or high voltage, we need a transformer to transform the electricity in a higher magnitude or lower magnitude. So depending upon the application and availability, we must use some different types of transformer for carrying a higher value of current and voltage. So for that, we need an instrument transformer. Now that instrument transformer mainly measures your electrical quantities like current, voltage, power, frequency, and power factor. Is known as your instrument transformer. They are mainly used in relay of the transformer, relay sensing the transformer. Okay, as here you can say, it is written what is an instrument transformer. Now you can say a transformer that is used to measure electrical quantities like current, voltage, power, frequency, and power factor is known as an instrument transformer. These transformers are mainly used with relays to protect the system. If let us say at the time of fault, we have the value of current of higher magnitude. In that case, we need to measure that much amount of current, that is how much current is flowing through the transmission line in times of fault. So for that purpose, we need an instrument transformer, and that transformer is normally named as a current transformer, because that current transformer measures the higher value of the current that flows through the transmission line during your fault system. So normally those instrument transformers are combined with your relay to protect the system. Okay, so this is a type of instrument transformer. And this is your type of instrument transformer. This terminal is named as S2. This terminal is named as H1. This is your high voltage transformer. This is the high voltage, or you can say your PT transformer. So it is a type of instrument transformer. Now the purpose of the main instrument transformer is written here. You can see the purpose of the instrument transformer is to step down the voltage. The purpose of the instrument transformer is to step down the voltage and current of the AC system, because the level of the voltage and current in a power system is extremely high. As you know, the power system carries 132 kilovolt or 440 kilovolt, 66 kilovolt. That much amount of value is carried by AC power system. So the instrument transformer is mainly used to regulate that high value of current and voltage in smaller value. So that's why this instrument transformer are designed. So designing the measuring instrument with high voltage and current is difficult as well as expensive. because for that value, for that higher value of the current and voltage, if you manufacture such equipments, that may be uneconomical, or or you can say mainly expensive, and to make the to make the economically sound the system, you have to decrease the costing of the manufacturing of the instrument. That's why we normally use the instrument transformer. Normally, instrument transformers are designed for the range of, let us say, your city. Current transformer is designed of the range of 5 ampere, and potential transformer or PT is designed for the value of your 110 volt. 110 volt is the maximum value for the PT, and 5 ampere is for the 5 ampere. Now, that 5 ampere will be divided in each section. That means, if that, let us say, if we have the value of 220 kilovolt is flowing through 220 kilovolt is flowing through the transmission line, then 220 volt is such adjusted in 5 ampere that each straight line or each needle will represent a particular value of current in the instrument transformer. Similar case occurs for your power transformer, or you can say potential transformer. Now, 110 voltage signal, the sign will be divided into equal distribution along the range of the instrument transformer, so that the actual value of the voltage that is flowing in the transmission line can be represented in potential transformer. Okay, so these are the main rating of the instrument transformer is given. Now, the measurement of it is written, the measurement of high level electrical quantities. High level, you can see here, this is written, high level electrical quantities can be done using a device, namely instrument transformer. Okay, that means higher value of the measurement can be done by using the instrument transformer, whether we are using current transformer or instrument your potential transformer, depending upon the application of the transmission, which quantity is flowing through the transmission line, or which quantity we have to measure. So depending upon that, the instrument transformer can be used. So these transformers play an essential role in your power system. Now, the type of instrument transformer is mainly given as your current transformer and potential transformer. The type of instrument transformer is given as your current transformer and potential transformer. Now, what is current transformer? What is current transformer? You can see that current transformer is written here, explained here. That is, this type of transformer can be used in power system. This type of transformer can be used in power system to step down the voltage from high level to a low level with the help of 5 ampere ammeter. 5 ampere ammeter, because current is always measured through ammeter. That's why we have used here the ammeter. Let us suppose, as I have already explained, if the high value of the current is flowing in the transmission line, then using the your current transformer, we can decrease the value of the higher current, and we can measure the how much current is flowing through the transmission line through a 5 ampere ammeter. The construction side is given here. As you can see, this is the construction or schematic diagram, or the schematic diagram of the current transformer, that how it is related with each other is given here. So the line is, this transformer includes two winding. This transformer includes two winding. Okay, like primary and secondary, just like your normal transformer which has two windings, primary and secondary, or you can say higher voltage or lower voltage side. This current transformer is also having two winding. One is named as primary winding, and second one is called your secondary winding. The current in the secondary winding is proportional to the current in the primary winding. As you can see, the current in the secondary winding, that is the current in the secondary winding is, let us take his name, named it as I2, is proportional to the current in the primary winding. Is proportional to the current in the primary winding. Let us say current in the primary winding is given as I1. So the current in the secondary winding I2 is directly proportional to the I1. It is not said directly or inversely, just it is written proportional. So we can take it as directly proportional to each other, as it generates the current in the secondary winding. Okay. So depending upon the number of turns, the primary and secondary current will flow in the primary side and secondary side of the transformer. Now the typical circuit diagram is given here. You can see this is your three-phase supply. This is your three-phase AC supply. This is a three-phase. Let us take, this is a red, yellow, blue. in either of them, a current transformer is included in the supply system. Here you can say this current transformer, we have the equal number of winding. Here also three number of winding is given. Here one number of winding is given. One is here G and D represents your grounding of the system. Then there is a ammeter. This will represent the needle portion. This will represent the needle portion or the range of the value of the ammeter. This is the switch that is at the time of operation. This will be closed, and at the time when it is not operated, then switch will kept as open. So this is the main circuit diagram of the connection of your current transformer. Now it is explained here. In this transformer, the primary winding consists of few turns. Primary number of turns will be lesser than that of secondary number of turns. Here you can say this is a primary number of turns. This is the core part of the transformer. This is the secondary winding. Let us say the primary winding will have two number of turns, and it is connected to the power circuit. Power circuit means this is your three-phase AC supply. This is your three-phase AC supply. So this primary winding of the current transformer is connected with the three-phase AC supply of the system. Three-phase AC supply, and that's why this is called your series transformer. So it is also named as your this current transformer is also named as your series transformer because it is connected in series with the power source, or you can say supply source. Whereas when you connect potential transformer, that transformer will be connected in parallel with the supply source. Okay. Now, in the secondary winding of turns, the number of turns is quite similar to that of secondary primary side, as depending upon the application, we can use the number of turns as higher value or lower value. That secondary will be connected to the ammeter, which includes a smaller resistance. Smaller resistance, that means your just like your parallel will be connected in parallel. Okay. So this is this is just mainly connection of your current transformer. This is the connection of your connection diagram of your current transformer. So you can see here the secondary winding of the transformer works almost in the condition of short circuit. So here you can see that this, if you close this circuit, then it will be look like this closed circuit, or you can say short circuit condition. So this winding includes two terminals where one of its terminal is connected to the ground to evade the huge current. So this is connected to the ground so that extra current or huge current will flow to the ground, and no damage will be done in the ammeter portion. No damage will be done in the ammeter portion. That is what is written here. So insulation breakdown chances will be reduced to guard the operator from huge voltage. Okay, fine. The secondary winding of this transformer in the above circuit is short circuited before disconnecting the ammeter with the help of switch to avoid the high voltage across the winding. Okay. If you want to remove the ammeter from the secondary winding of the current transformer, first we have to close the switch so that it can be removed, and the extra current will flow to the grounding of the say your current transformer. Now this is all about your current transformer explanation, that how much it is applicable and how much it is importance for your system to operate. Okay, for higher value of power system, or higher value of power system, and higher value of current flowing in the transmission system. So it is very important to use the current transformer for such practices. Now second one is your potential transformer. Second one is your potential transformer. Second one is your if you go through the potential transformer circuit diagram, you can see here the three-phase system. Then there is a fuse, there is a potential transformer, and a voltmeter is connected, and both of them are grounded. So wait for 2 minutes, then I will again explain the potential transformer. So we were discussing about the current transformer. Now it is time to discuss about the potential transformer. Now you can see here the potential transformer mainly deals with your voltage of the transformer. That is how much voltage it is measuring through the how much voltage is measuring through the transmission line flowing through the transmission line, that will measure through your potential transformer. That value of the voltage is reduced using your potential transformer, and the range of the potential transformer is approx 110 volt or 120 volt, depending upon the manufacturing side, whether whether they are converting that higher value of the voltage in 110 volt or 120 volt. So this type of transformer is mainly used to step down the voltage from a higher value to the lower value with the help of a small rating of the machine, small rating of the voltmeter, whose range from 110 to 120 volt. That is what written. You can see that this type of transformer can be used in power systems to step down the voltage from higher level to a lower level with the help of a small rating voltmeter, which ranges from 110 volts to 120 volts. A potential transformer typical circuit diagram is given here. So this is the circuit diagram of your potential transformer. This transformer normally includes two winding like a normal transformer. Okay, this is your primary side where fuse. This is the connection of your fuse. Okay, this is the winding, and this is the voltmeter having the smaller value of the range with respect to the other the higher value of the higher voltage. Okay, now this whole system is connected in parallel with the supply source, or you can say your power circuit source. This is connected in parallel, so it is also named as your parallel transformer. It is also named as your parallel transformer. So here you can see that this is your fuse. The number of turns that is provided in the secondary winding, the number of turns that is provided in the potential transformer of the primary winding is higher than the number of turns in the secondary winding. As you can say, voltmeter will have the lower value of the rating. So this voltmeter the voltage that will flow through this voltmeter must be lesser, must be smaller value. So for that value, if you decrease the number of turns, this can you can say number higher large number of turns will is converted into lower number of turns. That means larger value of voltage will be converted into lower value. That is, it is a type of step down transformer. So for the step down transformer, the value of the load side or voltmeter, the value of the voltage will be lesser. And for that value, if you denote the depending upon the range of the value, so if you divide the range in actual format, you will get the how much voltage is flowing through the transmission line. So that's why this is called parallel transformer, or you can say step down transformer also. Okay, this is your potential that both are grounded, so that the extra current will flow to the ground. No leakage or damage will be occurred to the this voltmeter, or you can say this potential transformer. So you can see here it is written similar to the primary winding, the secondary winding includes fewer turns. Here, in case of your current transformer, the number of turns in the primary winding is lesser than that of the secondary winding. But in case of this potential transformer, the number of turns in the primary winding is higher than that of the number of turns in the secondary winding. The number of turns in the primary winding is higher than that of the number of turns in the secondary winding. This is all about the potential transformer. So theoretically, it is given here. Theoretically, you can see here, it is named here. Similar to the primary winding, the secondary winding includes fewer turns, and that is connected to a voltmeter directly because it includes fuse resistance. Therefore, the secondary winding works approximately in open circuit condition. In the your current transformer, as we have discussed in the current transformer works at the secondary your short circuit condition, but this potential transformer works in the open circuit condition. Okay, one terminal of this winding is connected to the earth. As you can see, one terminal is connected to the earth to maintain the voltage with respect to the earth to protect the operator from a huge voltage. Like if it does not connect to the earth, then much higher voltage will flow through this transformer, and the operator which is operating in this site in the potential transfer, they can be easily get shocked with the electricity. That's why we need to provide we need to we need earthing for this potential transformer. Okay, so this is the main connection diagram. So this is the main connection diagram of your potential transformer. What now? What is the difference between your current transformer and what is the difference between your current transformer and potential transformer? It is written in this format. There use number of points that is given in the current transformer, potential transformer difference. So let us introduce one by one. What is the difference between current transformer, potential transformer? So it is given here, the current transformer. This connection of this transformer can be done in the series with the power switch. As you can say, this current transformer is a type of switch because the current transformer primary winding is connected in series with the power circuit. That's why this is named as your series transformer. Similarly, potential transformer, the connection of this transformer can be done in parallel with the power circuit. As this potential transformer is connected in parallel with the power circuit through fuse. So that's why this is also named as your parallel transformer. Okay. Second point is the secondary winding is connected to an ammeter for the current transformer. In potential transformer, the secondary winding is connected to a voltmeter. Okay. Because of this current, you can see that this ammeter is correlated with your current, and this is the voltmeter. This voltmeter is correlated with your potential transformer. Next one is the design of this can be done by using the lamination of silicon steel. Okay. Now the designing method of your current transformer is through your silicon steel. Now for the same process, for the designing purpose, the potential transformer is done. The designing of the potential transformer is done by using high quality steel which operates at low flux densities. By using high quality steel which operates at low flux densities. So this is the designing method. Next one is here, the primary winding of this transformer carries the current because of this is a current transformer. This is your primary winding will carries the current. Similar in potential transformer, the primary winding of the transformer carries the voltage. This is the basic thing. Next one is it includes less number of turns. That means the primary number of turns is lesser than that of the secondary number of turns. Whereas in potential transformer, the primary number of turns is higher than that of the secondary number of turns. Okay, so this is the difference. Next one is the secondary winding of this transformer works in the condition of a short circuit. Secondary winding of this transformer works in the condition of a short circuit, as we have seen in this. This is a condition of short circuit condition. This works on the condition of short circuit. That is what given here. The secondary winding of the transformer works in the condition of short circuit. The second part is the secondary winding of the transformer works in the condition of an open circuit. Okay, the secondary side of the potential transformer works on the open circuit condition. Okay, next one is the primary. The primary current mainly depends on the flow of current within the power circuit. That means the current flowing in the primary winding of the transformer here. This is the primary side. This primary number of turns, the current flowing in the primary number of turns will totally depend upon the how much current is flowing in the three-phase AC supply. Similarly, in case of your potential transformer, this primary number of turns carries voltage that totally depends how much voltage is flowing through this power circuit. Okay, so you can see here the primary current mainly depends on the flow of current within the power circuit. Similar, the primary current mainly depends on the secondary load. That is for the potential transformer. How much load is provided to the potential transformer on the secondary side, that will depend how much current will flow in the primary side. That is what is given here. Next one is the insulation breakdown can be avoided. The insulation breakdown can be avoided by connecting the secondary winding of this transformer to that. As the insulation, this is the insulation or the protection or safety purpose point. It is written here. The insulation breakdown can be avoided by connecting the secondary winding of the transformer to that. So here you can say the secondary winding of the is earth. This is your grounding is done. Here also the earthing is done to protect the transformer. So that is what's written here. The insulation breakdown can be avoided by connecting the secondary winding of the transformer to the next one is the potential transformer. It is written the secondary winding can be connected to the earth to protect the operator from a huge voltage. Okay. Now the range of the current transformer is 1 ampere or 5 ampere. The range of the potential transformer is 110 volt or 120 volt. Okay. It is not even a 120 volt, but you can use 110 volt or 120 volt. Next one is the transformer ratio. It should be transformation ratio K, that is N2 upon N1 or I1 upon I2 or V2 upon V1. That is transformation ratio. The transformation ratio of this current transformer is higher, and the transformation ratio of this potential transformer is lower. Now the next point is the input of this transformer is the constant current, and in the potential transformer the input of the potential transformer is a constant voltage. Next one is this type of transformer is classified into two types, like wound type and closed core. That is, current transformer is mainly classified into two types, that is wound type and closed core. First part. Second one is this type of transformer is classified into two types. This type of transformer is classified into two types. One is electromagnetic and another is your capacitor voltage. One is your electromagnetic and another is your capacitor voltage. Okay. Next point is the impedance of this transformer is low. The impedance of this transformer is low because of the higher transformation ratio. The impedance means the inclusion of your resistance and reactance. The impedance of the transformer is low, but the impedance of the transformer in the potential transformer is higher. It has higher value. Next point, last point, difference of potential transformer, current transformer. It is given here. These transformers are used to measure current, power, monitoring the operation of power grid, and protecting. Okay, this is the main function of the machine. Mainly, current transformer is used to protect the system, and it is combined with the protective layer to protect the whole system. As relay is a sensing unit which senses the fault and which gives the reaction to the circuit breaker to break the circuit from a healthy part to an unhealthy part. So that is the main purpose, and in inclusion with the protective layer, this higher value of the current transformer is operational. Similarly, in the next part, it is given here. These transformers are used to measure operating, protective relay, and power source. Okay, so these are some different points or difference between current transformer, potential transformer, of the instrument transformer. So all of you must go through this. In the next class, we will study about the testing of the instrument transformer and the advantage and disadvantage of the instrument transformer. Okay. Then there are some practical appliances we will discuss. These are some practical appliances we will discuss in the next class. So next class, in the next session, just join within 5 minutes so that you can do this left out part, so that this topic will be completed then. Okay, so all of you must leave the class. Okay, join in the next session within 5 minutes. I'm going to end this session, so all of you must join the next session within 5 minutes.